Simple Java 3D code using SharedGroup. Let's change expressions used as arguments with SRC. Voice by ondoku3.com. In this video, we will change variables, expressions, and numbers used as arguments. To see what happens. These variables and expressions specify each position of the local coordinate system for a color cube, which is an illusion, and actually just one object, but looks many. The SharedGroup class is very useful for creating backgrounds. Using the class easily allows us to regularly arrange objects of the same shape. Such as buildings. Or trees. Or to place rocks randomly on the ground. Or around Saturn. Not just a background, the class is also useful for moving a group of randomly placed objects together. Or moving a group of randomly placed characters together. Using the class saves memory since only one object is actually created. You might think that for something like a color cube, we don't need to worry about saving memory. However, there is another key advantage of using the class. Using the SharedGroup class within nested for loops. Allows us to automatically handle the regularly changing positions of the local coordinate system. Without needing to manually specify them each time. This approach not only saves memory but also simplifies the code by eliminating repetitive transformations. Without using the SharedGroup class. If you directly connect a color cube to TG-Link like this, multiple parent exception occurs. All we can do is to create multiple local coordinate systems with different names. And manually specify the position of each local coordinate system one by one. This is really time-consuming, so let's use the SharedGroup class. As I said earlier, the purpose of this video is to try to see how the positions of color cubes change. When we change the above variables and expressions. This is a fun part of learning Java 3D programming intuitively. I won't go into detail here about how the SharedGroup class and the link class are used. to create illusion objects within the nested for loops. I've used these classes many times in previous videos. So if you are interested in how 3D models are placed using the class, check out the following videos. How to make one object look many 540. Java 3D, how to create a simple building and ground in Blender and import them 915. How to put a downloaded free blend swap model into Java 3D and manipulate it 42459. Java 3D, how to place gondolas local coordinate systems in a ring 1120. I provided 5 types of source code. Source code 1. Placing 2 lines of color cubes receding along the z-axis on an XZ plane. When x equals -3.0 f, z changes like this. -360.0 f, -355.0 f, -350.0 f, 30.0 f. When x equals 3.0 f, z changes like this. -360.0 f, -355.0 f, -350.0 f, 30.0 f. So within the inner for loop, the z position of TG link changes like this. When x equals -3.0 f, when x equals 3.0 f, as a result, color cubes are placed like this. You can navigate in a 3D space by using arrow keys. Transforming from straight lines into sine curves. Suppose th is initialized to 0.0 and increment by 0.3 within the nested for loops. What happens if you multiply x by float math sine th? The scale is made smaller so that each color cube is made smaller. You can clearly see that color cubes are forming 2 lines of sine curves. Source code 2. Graphing an equation using color cubes on an XY plane. To graph an equation on the XY plane, since the z value is always 0.0, remove this part. And change the x value in smaller increments. To display all the color cubes properly, adjust the scale. And move them by 20 toward the back. What happens if you change the y value to x? Since this is the y position of TG link, the graph of the equation y equals x is displayed. What happens if you change the y value to x multiplied by x? To display the graph in the center of the screen, I changed x multiplied by x to x multiplied by x minus 5.0. So that all the color cubes move down by 5.0. Since this is the y position of TG link, the graph of the equation y equals x multiplied by x minus 5.0 is displayed. Source code 3. Graphing an equation using color cubes in an XYZ space. To graph an equation in an XYZ space, an inner loop is needed. Describe nested for loops like this. To display all the color cubes properly, adjust the scale and move them by 20 toward the back. What happens if you change the y value to x multiplied by x plus c multiplied by z? To display the graph nicely, I changed x multiplied by x plus c multiplied by z to minus open parenthesis x multiplied by x plus c multiplied by z close parenthesis divided by 8 plus 2.0. The graph of the equation y equals minus open parenthesis x multiplied by x plus c multiplied by z close parenthesis divided by 8 plus 2.0 is displayed. Source code 4. Graphing an equation using points in an XYZ space. This is the code for connecting a created color cube to a shared group object. This is the code for creating a point. This is the code for connecting the point to a shared group object. Replace the code for adding the color cube. With that for adding the point. Remove this part to change the background color from white to black. You can display a more beautiful graph of the equation y equals minus open parenthesis x multiplied by x plus c multiplied by z close parenthesis divided by 8 plus 2.0. Source code 5. Randomly placing color cubes on an XZ plane. This is the code I initially used. To place 2 lines of color cubes on an XZ plane. To place many lines of color cubes over a large area. Describe nested for loops like this. To display all the color cubes properly, adjust the scale. and move them by 30 toward the back. To view the scene from a little bit above, move them down by 1.0. What happens if you execute the program? Many lines of color cubes are displayed over a large area. To randomly place color cubes, use Math Random. Which returns a random value greater than or equal to 0.0 and less than 1.0. Multiply X by Math Random and Z by Math Random. What happens if you execute the program? At first seemingly okay. But if you use the up arrow key to zoom in, you will notice something wrong. The color cubes at X position 0.0 are aligned in a straight line. This is because when X equals 0.0, whatever you multiply by X is always 0.0. So the X position is always 0.0. To prevent this, I changed X to X minus 5.0. Now, color cubes are scattered completely randomly. Executing each source code file in Eclipse. Source code 1. Normally, the following dialog box is displayed. Select MikeyNavB, default package. Two lines of color cubes on an XZ plane. Two lines XZ plane. Right-click. Copy. Paste. Two sine curves XZ plane. Copy. Click. 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 4 parentheses. Double th equals 0.0. Initialize angle th to 0.0. th plus equals 0.3. Increment th by 0.3. Multiply x by float math sine th. 0.08. Two sine curves. Source code 2. The graph of the equation y equals x. Y equals xy plane. Copy. Four parentheses. X multiplied by x minus 5.0. The graph of the equation y equals x multiplied by x minus 5.0. Source code 3. The graph of the equation y equals minus open parenthesis x multiplied by x plus c multiplied by z close parenthesis divided by 8 plus 2.0. Source code 4. The graph of the equation y equals minus open parenthesis x multiplied by x plus c multiplied by z close parenthesis divided by 8 plus 2.0 using points. Source code 5. Randomly scattered color cubes on an XZ plane. On my homepage, new Google Sites. I divided my how-to videos into groups so that you could find what you were looking for more easily. If you are interested in it, please visit the site. Links in description. Visit my channel to see more videos.